G'day viewers, and welcome back to the channel. Today's episode has been a long time coming, and I'm excited to showcase our advanced steel system, which at its core was focused on the automation of the documentation set, so they would flow from cover sheet right through to the single cleat parts. I hope by demonstrating the workflow that I've developed over many years, it will provide some hope to other users that are still learning advanced steel that it can produce half reasonable documentation, albeit it takes a mountain of customization work to reach that point. If you were to ask any advanced steel user, I would suggest most would agree that the modelling side of advanced steel is simple enough, but the drawing outputs from the out-of-the-box system presents quite the challenge to produce quality drawings. But more importantly, produce those drawings in a highly time-efficient manner. The system I've developed had to be capable of both producing the engineering drawings and the fabrication drawings. What I will demonstrate today is our workflow to produce these two separate sets once the design model has been completed. I will first run through our new SysDef custom drawing processes palette, create and export a material summary list, a bolt and anchor list, and a purl and takeoff, followed by the creation of the engineering set and then the fabrication set. Once those sets are created, I will then create a full set of PDFs for us to review. I also just want to note that some of the output drawings still require some manual minor tidy-ups. There are still certain parts I either can't yet or have not had the time to completely automate to 100% perfection. I hope you would at least agree with me that our automation system, as it currently stands, is still a vast improvement to the out-of-the-box offering from the software vendor. I can only hope that this solution of ours will save the industry thousands of hours of work and years of frustration trying to beat advanced steel into submission to deliver projects for our clients. So with that, grab yourself a coffee and let's take a look at our system. Okay, today we've got we're running 3 monitors. So we have our top right hand corner, we have our main monitor with advanced steel running. Top left we have our Windows file explorer, and on my right hand monitor I have HW info running and our processor Lasso, just to watch some system hardware resource utilization. So let's move now to our main monitor and our first item on the agenda, which was to look at our new SysDef drawing processes palette. So we can see here we've got a custom palette. Let's just go back. You can see this is the out of the box version. Here is our SysDef customized version, and we have a list of processes in order of how our drawing set flows. So from the top here we have our process for which starts off our engineering set, and it contains processes to produce items such as like the cover sheet, the engineering notes, which we have 2, so we've got 2 engineering note pages, and we also produce some isometric views. In today's application we are going to produce 4 drawings for isometric views, but you could create 1 or 100 if you wanted to have that many isometric views. Then we go through into our engineering drawing set, which will produce again some isometric views, engineering plans, engineering elevations, sections. You can do hold down layouts, support layouts, and engineering details, so all your cameras that produce details of steel connections, base plates, that type of drawing, those details. The next process on the list is the beginning of the fabrication set. So this is where we would create again a specific cover page for the fabrication set. We've got fabrication notes. So again, we've got two pages of fabrication notes and some isometric views there as well. Next on the list for processes, we have our marking plans. So these are our marking plans to provide information to help people find out where to get information about either the assemblies, mostly the assemblies, or standalone beams or standalone parts. So we've got marking plans there for, once again, some 3D views with labeling, marking plans, elevations, sections, again, hold down layouts, supports and details. If you've got specific details that are needed for the fabricator, then we can create some details there. Next on the list, we have our assemblies. So we've got 3 processes here, but inside those processes there are lots of different drawing styles that manage the output of drawings, but we've broken it into 3 distinct areas. They are stick assemblies, welded frames, and welded components, which at the moment is on an A1 sheet, but we think that would be better served to make that an A3 sheet, because it's really about doing welded componentry and brackets that probably don't need to be on an A1 sheet, unless we think that there's a lot more detail that needs to go into those welded components. Then we're into our fabricating single part processes, which we've split up into different groups so that it basically groups different types of single part material processing. So we've broken it up into the hot rolled elements for mild steel, and mild steel cold formed elements. So these are your hollow sections, so your RHS, your CHS, your SHS, those types of elements. We have what have we got there? So we would have the alloys, so your bisalloy elements. What else? So you have some mild steel. So we've got curved beams as well. Stainless. We might just see if we can change that back to. Can we get down to 40? No, we can't. So I thought I might be able to make that a little bit wider. Doesn't seem to want to let me. We'll put him back there. Stainless, so stainless plate work, stainless sections. Then we have an area to group together aluminium sections, aluminium tubes, aluminium plates. Then we're into timber, so we've got all our timber elements, concrete slabs, masonry parts. So these will group all those parts into areas in the drawing set itself. Next on our list are fabricated components. So these are single parts, but these are components that are on A3 sheets. So normally these are managed by model rolls, and typically they are the smaller elements. So it might be a tread bracket or an outrigger, those smaller items that don't need to go onto an A1 sheet. we will put those onto an A3 sheet, but we group them by the material type. So we will have a group of mild steel, stainless, aluminium. So you can have that group in the drawing set that you might give to a specific fabricator who specialises in aluminium or stainless or mild steel. So it doesn't put all those items throughout your set. It groups them together in an area which makes it easier to grab and find. Next on our list is our light gauge steel. So these are our purlins. Again, we've broken that up and separated those into groups. Those groups are like purlins, which are your traditional purlins and girts. We separated out nesting channels. We also separated out the light gauge steel for wall framing, if you do that, and also your flashing. So if you're detailing and modelling your flashings for barges, gutters, folded material, you can keep that in a separate group, because you may outsource that to a specific company to do that sheet metal work for you. Next on the list are our cleats. So these are all our what we class as non-standard cleats. So they're cleats that aren't coming from a standard parts library. So they don't exist in a standard parts library. So we call them non-standard. But again, we've grouped them by different materials. So you may want to send your mild steel off to a laser cutter. Your stainless you might do in-house. Your aluminium you might buy those from another supplier. So we've grouped them by mild steel, stainless, aluminium, and the alloys, so the bisalloy type materials. Next on our list is for our standard library. So these are coming from the standard library. If you've got standard cleats that you bring into your job, these are grouped in a separate part of the drawing set, and again they are classified with their material type. So again, mild steel, aluminium, stainless, and those sorts of separations. And lastly on our list we have an area for manufacturing. So we've got assemblies for manufacturing. At the moment we've got two processes in that group. We've got one for doing drawings for light gauge steel wall framing, and also one for doing timber wall framing. So these are drawings that you can then give to a company to do their roll forming of and manufacturing of prefabricated wall frames. You can detail those up and share them with them of what they actually want. I don't believe that those files can actually be put through their roll forming machine, but at least you've got half a chance of getting those assemblies or those wall frames made to the correct size to fit into their locations. So that is a very quick overview of our drawing processes palette, and I'm sure in given time that it will continue to grow, and more processes and more specific needs will arise with people's requests. Okay, so that was the drawing palette. Next on our agenda was to create the material summary list, the bolt and anchor list, and a purlin takeoff. So let's take a look at that that activity there. So we've got ourselves a model here. So we've got a very basic portal frame shed that we're going to use for today's example. So I'll just minimize that and bring up our templates, and we've got our material summary list here. If it would run for me, that would be nice. Let me just, I've got a command open here, that's probably why it's not running. There we go. Now we're getting some action happening now. There we go. So we've obviously numbered our model and everything's been checked, and this is our material summary list takeoff, and you can see how it splits it up into the different types of profiles, rounds. These are 10 plate, 16 plate, 20 plate. We've even got special parts in here, and I believe this particular material summary list also includes purlins. It could be that you do want to take them out, but we've included them there for a complete material summary list, although we do create a specific output so that fabricators can give a purlin list of just purlins to their supplier. So we can export that now. We'll export that to an Excel file, and we can export that now. You can see down here we've given this particular material summary list a document number of 601-01. Okay, close that down. We'll save that, yes. Right, so that was a material summary list, so you get an idea of what they look like. Next we'll do a bolt and anchor list. So we've done quite a bit of work with our naming conventions with the bolts and anchors to actually reflect the correct terminology, particularly for Australia. So this is our bolt and anchor list of all. So we do have some BOM outputs if you want to separate bolts for shop or for site, and also if you want to separate bolts and anchors. In this case here, this is a list that includes bolts and anchors as a list. So you can see on our list here that we have got our marking numbers, so we number our bolts. So here we've got a quantity of 8. It's a bolt, it's in 01, which will tell us that it's in the lot and phase 01 bolt, and it's given a number of type 01, and it's telling us the grade. So it's a AS 1252, which is a structural bolt in Australia. It's also telling us the size here, and then we've got a terminology of it's an M20 and it's 65 long and it's grade 8.8. Surface treatment galvanized. Weight. So then we've got all that. We do have some other features in our modeling process whereby we can add information about those bolts. If you needed to group those to be in a certain group for a certain level or a certain part of the construction stage, you can put that information into the predefined remark. And if you have other comments that you may wish to add about embedment length or the process, you can add information to the bolt in its free remark, and it will show up on this particular list here. So let's save that or export that to Excel. We'll exit out and save. Right, then we've got our purlin list. So purlin lists are a little bit different to create, so we have to go to our BOM editor to do this. And we go to our purlin list. We'll use our purlin list, and we'll use this grouping here for the selection. And here you can see we've got our purlin list. So again, we've got our part mark numbers on the left hand side, also the profile, that's always handy. So it's part number, so we've got PRT for our part. 01 will tell us again it's lot 1, FP for a fascia purlin for its prefix, and its number 400. Model roll, its description, we've got supplier information, a part length, the total number of length, we've got our material, so our material is broken up by material, then it's the grade and the surface treatment, or the surface treatment plus the coating. So in some cases you will need to go, well, I have a particular element that is mild steel, it's grade 300 and it's black, but it gets painted as a secondary process. So this material value here is about the type of product that you're actually buying from the steel merchant. So you need to know what sort of material it is, so mild steel, what grade of mild steel it is, and what finish, because some of these steel products will come in black, they might come pre-painted, Duragel, some might come hot dip gel, some have special coatings that you order, like even with aluminium products you might have a mill finish or a polished or a semi-polished. That information is contained in the material list, and then the coating might be a powder coating secondary phase to that. Obviously part weights, okay, so, and then we've got all our weights at the bottom. So that's our purlin list. We'll export that to Excel, and you can see the number here, we've got 601. So 601 is a designation we give to all our BOM outputs, and this is list type 10. And we'll save that. I thought I said, oh, that's in the BOM meter, we don't need that anymore. Okay, so that was the BOM outputs that we looked at there. So we've covered that off now. So the next part is to set our, so we're going to start creating our engineering set. So the first thing that we need to do before we do that is go into our management tools. So I'll go into our management tools, and I need to set one of my settings here. So under drawing general, if we come down, if you can see here, the start number for drawing numbers currently set at 200, which is what we use for our fabrication set, but we are creating our engineering set, so we need to set that for 100. We save that, and we will also just save that or update our databases so that that's ready to go. All right. So I've got, you've probably seen my little yellow timer up here, so I thought what I would do is run these processes and time it. Obviously you don't want to sit through the time it takes to actually run some of these processes, so I will run these processes, and we will basically speed that up so you don't have to sit through all of it. So let's start with this first one and run the process. So we come up here to our output, and we come into our drawing processes. Well, if I'm in the right button, that might help. There we go. This is the process design switch. This is an area I think is one of the most underutilized tools in advanced steel. And here we have a bunch of drawing processes that we can run. So if I wanted to just do a check on some cleats, I could run a process just to do cleats. If I wanted to just do some drawings of my marking plans, I could run these. I've got a full set. If I wanted to run both the engineering and the fabrication set all the way through with both sets, I can do that basically as a preliminary check to see if all my model rolls and everything is working nicely. I can delete that set and then come back and do this, make this change where we use the 100 series for our engineering drawings, and then the 200 series for our fabrication. So that is why we separate them out, and that's generally the case, that you'll produce your engineering set first to be reviewed, and once the engineer is happy with all the modelling and the connections, then you can move on to the second phase of the fabrication drawings. But there are some times when you can issue both the engineering drawings and the fabrication drawings at the same time to speed up the process. Okay, so let's run this process now. So that's now running. So what it's going to do is now use the system and the coding that I've put in place to run. So we better also start the clock. That would be a good idea. So that's off and racing. Okay, so that's completed. That actually didn't take as long as I thought, so we'll just stop it there. So that took 1 minute and 48 to create that engineering set. So now that's created, let's take a look at what it created. So we'll go to our document manager and have a look at the drawings that it created. There you go. So there we've got our drawings from 000 down to drawing 118. So we do a bit of a preview here. So we've got a cover sheet. We've created what should be the general notes. Let's hopefully see if it's created in the right order. So our first engineering notes, this will be our second engineering notes page. And thirdly, so we're getting into now some isometric views. So this is where I've allocated drawings that can be used to insert an X reference. So let's show that process. We won't obviously do all of them, but let's do at least one. So here, this is our drawing. We can go into our model space, go to our X reference, go to the model that we are working on. We can insert that model. I'm just going to turn off the def points layer. We don't want that in our drawing. We can come back to our paper space. We'll go into our viewport and we'll just do an isometric view here. I did a test on this earlier. I believe the scale at 1:40 is going to, if I could type properly, that would be a help. There we go. 1:40 is a decent enough scale. So that is the a 3D isometric view. It for me, I believe that just a little bit of color in the drawing set and a visual representation of the structure that the reader will be looking at helps to start the introduction to the drawing set. So it helps to build the image of what the drawing set will follow. So we're out of there now. So this is just done through a viewport, which I can't actually see at the moment. Where is my viewport layer? There should be a viewport there somewhere. I just can't seem to see it at the moment. But anyway, so the idea was this: you could have just the one view. In most cases, we actually use 4 views, one on each page, but you could actually put 4 of these views on the one page if you felt that that was sufficient information for the fabricator. Okay, so let's just save that drawing now. So we'll save that, and we'll come back to our drawing manager, and just to separate these out from our second set, we'll just add some information to these drawings. So in this case here, we will add for approval, and we might even put a revision in here as well. So let's just put a revision in here, add by myself, and let's say issued for engineering approval. There we go, and let that update. Okay, so that is our engineering set done. Let's now create the fabrication set. So as I mentioned before, we use a different numbering system for our fabrication set. So we firstly come into management tools, we come to our defaults, we go to drawing general, down the bottom, start number for the drawing numbers, and we'll change that to 200. We'll save that, close management tools, update the databases, and we are good to go. So we can now go to our output part button on the ribbon, excuse me, go to our drawing processes again. In this case we will run our full fabrication set. We will use that. I'll just reset the timer. There'll be quite a few more drawings in this set. I didn't actually count how many was in that last set. There was probably around 20 or 30 drawings in that engineering set. So what did we say, a minute 40 or minute 48, quite quickly. This particular set, I would say we're going to be somewhere between 100 and 200 drawings, I imagine. So let's say 150 drawings. So we'll let that run. Again, we'll just do a timeline speed up for you, so you're not having to sit through this drawing production, and we'll come back once they're completed. Okay, it looks like that drawing process suite has completed, and it has taken just over 6 minutes to run that process through. So what we have done now is we have created both the engineering set and the fabrication set. So the next thing that I would do is come over to my queries, and I have some queries for doing things like looking for missing single parts. So by highlighting this, it's telling me, okay, everything has now got a single part, so that nothing's missed from the drawing processes. And missing assembly drawings, so if we just spin this around, there are some standalone parts that don't have part of assembly, so like fly bracing and purlins and girts and turnbuckle rods. So that is a query that we run that helps just double check to make sure that a new model roll wasn't added or incorrect, so it didn't actually create a drawing for those. And then again, here's a selection set just for our model rolls that are light gauge steel, purlins, girts, fascia purlins, purlin trimmers, those sorts of model rolls. I'll turn that off now, if it would allow me to turn off. There we go. Okay, so let's now go to our document manager and see what the fabrication process has created. So we can see up the top here, these are our engineering drawings that we created first, and now we have our secondary set below here, which is our fabrication set. So you can see it has its own cover sheet for this particular set. So let's go to the 1, 2, 3, this one here. I think this will be our first isometric view. Oh, it's not. Go try one more. There we go. Let's open up this drawing. Right, and we'll go to our model view, and again let's drop in an X reference. Oh, I've got the X reference dialog box open. There we go. That's our model that we are working on currently. We'll drop that in to that position. So I worked out why I couldn't see my viewport before, because it'll be on the def points layer, which is I turned off. Yes, it is. So again, let's drop that in. But as I mentioned before, you could put in here 4 views. So let's just create some construction line work here. And let's just stretch. Try that again. So I'm not sure what scale this would be. Let's try 1:75. That's probably good enough for today's exercise. Right, so there we have one. Let's just copy this around. If I can pick up on the viewport, that would be nice. There we go. There. There. We can then go into each of those viewports and change the angle. What did I do? 75 for the scale. Shift him over. Is to 75. Let's just drop him in there so it sort of looks half reasonable. Obviously, having more time, you could make that setup much better and put a couple of title blocks. We have a title block there, so you could copy that round and move around to make it set out much better than what I've quickly done there. But I can turn off. I'm going to turn off the that def points layer, because there's a layer in my model which shouldn't be there. But we'll solve that. There we go, solved. That still makes sense. We'll save that. If I could spell save. There we have it. Save and exit the drawing. So that is what I call the coloured isometric views. And let's now add some information in here. Let's just go straight to fabrication. And let's add a revision in here. Let's add again my name and issued for fabrication. Hit the OK. It'll go off now and populate those parameters. Hit OK. Let's just save our model. Okay, that is saved. So the next thing we wanted to do is create a set of PDFs. Now I'll just reset the clock because I know we want to run this again, because the time it takes to actually run the PDFs can be the same amount of time that it takes to produce the drawings. So let's have a look at that process. Come up the top here, we'll pick all the up-to-date drawings, we'll add to a batch plot. Choose a plotter. In our case we're going PDF, and we're going to go put them all onto multi-sheets. That'll combine them all into the one PDF file. Now interestingly, when you create your PDFs, you must make sure that you don't have the PDF that's going to be created, you don't have that open. If you have that open, when you run this particular process, it will run the process, but it won't save the file and you'll have to rerun it. So it's preparing the drawings now to be plotted. We'll hit the start button to start the timer, and we've got 163 drawings in both the engineering and the fabrication set. So 163 drawings. So I think the old way of manually producing all these drawings, I think, is quite time consuming and can take quite a while. So I think you could see how this process of being able to automate the process to create these drawings will save the users a lot of time. And not only that, what we have found is that the ability to run these processes multiple times on a project, so you don't get to your deadline and start testing to see if these drawings are going to come out correctly. You can run this process several times throughout your process or your drawing design and modeling, and pick up on errors. So when you get close to your deadline, you know that your drawings are going to be very, very close to a final product that will only require some minor tweaking to tidy up drawings at the end. So you're not concerned about things which I've had in the past, where you get to the deadline and your concern are the way you've modelled, is it going to work with the drawing styles. With these processes, running these halfway through a project, once a day, once every few days, you can really keep an eye on how the drawing set is progressing and give feedback to your team about how they're going, maybe make suggestions to change a model role because a drawing style would better suit it's an output. So again, I won't bore you with sitting through 163 drawings of PDF creation, so I'll let you let's just Okay, we're getting pretty close now to the end of this set. Only a few drawings to go. So from memory we had around a minute 40 for the creation of the engineering drawings, 6 or 7 minutes for the creation of the fabrication set, and now in the range of 8 minutes to produce the PDF set. So there you go, so just over 8 minutes to create the PDF. I'll just go to this drawing, so this monitor set up here. So we've got the PDF set opened up on my other monitor. I'll just move up. Page up, yes I can. Alright, so we're at the top of the set, so we might just bring this up here. There we go. Okay, so let's have a review now of our both our sets, our engineering set and our fabrication set, to see what it's actually produced for us. So we have a cover sheet, general notes. There's that 3D image of the overview, isometric view, some empty pages that we didn't do, some more isometric views which are created from advanced steel cameras, which you could label if you wanted to label. In this particular case I've got a couple of styles. One is a style that includes the purlins and girts, and one that just shows heavy steel. For me, I believe it just it helps with the understanding of what's coming. I've got a general arrangement drawing here. This is an engineering drawing, so it will tell us the type of object it is, a mullion or a column, and the size of that member for engineering purposes. Here's a roof plan of the structure shot, once again showing our model rolls and the member sizes, elevations. You can see all our title blocks have been filled out. It's an engineering set, it's an elevation, sections. So you can see here that we've got our grids set out, and there's some tidy up that will be required here. So, but it's a starting point to assist the process. Some grid sections. Then we've got our hold down bolt layout. So just tell you once again, you can see some of these notes. I can't get those to play nice at the moment, but to tidy those up is not a difficult process. We've got our hold down bolt or layout, so we would come in here and we would manually remove the set out part and just call this a hold down layout. But then we have our hold down set out, so then we would remove the layout information. This is quite a good one, a drawing style that we've created recently with showing our base plates and anchors. I would like to get to the next stage of actually dimensioning all these anchors off the grid line. So I've got a bit of work there to do that. At the moment we manually put those dimensions in. Now we're into our details. This is basically filling up drawings. I would say that filling up our drawings before it goes to the next page. So I would come in here and tidy this up, and I would say we would probably move some of these details onto a sheet to fill it up a little better. So, but at least it's got that information as a starting point that we can remove some of the labels that we don't want or are superfluous. So again, some more details, which as an automated output, compared to what we were producing 7 years ago, is I would say vastly improved. So now we're into our construction detailing set, or a workshop fabrication set. We've got a bit of a list here of how the set is broken down, which follows those drawing processes that you would have seen in the SysDef drawing process palette. That follows this grouping or this breakdown. So these are specific notes for fabrication. Also, something we've done recently is add all our model abbreviations to our set. So we're starting to build up these general notes to provide some information for people to help them understand how our drawing set is put together. The next step to add to this, we want to add our welding symbols that we use for our macro onto this page, so it's very clear to people who are either used to seeing a different standard or want to have some clarification around the symbol, or just a reminder if there's a certain weld symbol that they haven't seen for quite a while. So these are isometric views that we would put in here. I think I mustn't have saved that one that I did before. Okay, so here we got into our marking plans. So these are our marking plans with our assemblies. So you can see that we have assemblies, and some of our standalone parts, like our fly bracing, are calling up the part number, which is actually what we want. This is something that I only solved very recently, and I did a video on that very recently. So again, you can see how we have some views here without light gauge steel and with, so you can basically change your drawing style and tidy this up to just denote the light gauge steel labeling. So we've got a column marking plan, a roof marking plan, some marking elevations, marking sections, and then we're into our stick assemblies. So stick assemblies, and again there will be tidy up required. There's still dimensioning that we want to improve on here, but it's certainly, again, it's a starting point to get it onto a page to then tidy up. But we would like it to get to a point where there are virtually no manual tidy ups, but you can see how it just needs a tidy up on the page to present better. So here's our stick assemblies for a column. We've got our custom bomb schedule up the top right hand corner. Gives us the assembly number up the top here as well. I find that very useful. So stick assemblies, there's one that needs a fair bit of tidy up. There might be some sections here that aren't required. We might delete some of those. So we're into some eaves ties. So again, still some stick assemblies. Some mullions. Rafter. Still into stick assemblies. We're into a door header here. Well, actually, we've gone from assemblies into single parts. So single parts, mild steel, hot rolled. So here are it's a hot rolled single part. Obviously, that doesn't have any cleats welded on it. Some columns, these are all the single parts for the columns. And if we go we'll just go back a drawing, that's our hot rolled group. Now we're into all our cold forms, so all our RHS, SHS, we'll group those together because that might be processed differently. So these are some little things that I would go back and edit in my model. The system lines, that if they are longer than the object, do this, but you do want to keep your system lines for dimensioning. So these are some things that I would go find and go, right, I can tidy this up which will then present better in the drawing set. Again, same issue. So now we're into single part mild steel components. So these are small elements that are on an A3 sheet, so no need to have an A1 sheet. So they're single part components. We're now into, so we've gone from components into light gauge steel purlins. These are fascia purlins, roof purlins, girts, some trimmers. Now we're into our single part mild steel cleats. So there are cleat drawings. Oh, there we go. So these holes here should be blue like the rest of them. I would say there is an issue with a bolt, or the how that is actually. I'd go back and look at that. I think there's something modelled slightly incorrectly. I would say maybe the bolt is slightly skew-if on that particular connection. So this is the beauty of this ability to create these drawings quickly, that you can go through and you can spot errors like this and then go back, fix the model, maybe update this one drawing, or delete all the drawings and then reproduce them quickly. So yes, so that is our drawing set. So okay, I hope this video has been of value and provided some insight into what can be achieved with advanced steel. This is a solution that we have built to assist the wider steel structural design and steel detailing industries to deliver projects faster and with less frustration. So what is our roadmap ahead? Well, I can assure users we are not finished yet. There is still much to be done to continuously improve our system. Items on my radar are things like concrete plate elements, more drawing and dimensioning styles, stair and handrail drawings, a decent bridging macro, custom part libraries, just a few to mention. So if you have any questions, comments or suggestions on how we can improve our drawing production and automation solution, by all means post those comments below, and I look forward to reading those comments. Thanks again for watching, and remember, if your job's worth doing, it's worth doing right.